Good afternoon, dear students. Can you hear me?
Yes, I can, teacher.
Yes, we can, teacher. I have a question for you. You said last week this one's homework, but do the homework, but I couldn't see the homework. And should we submit anywhere?
Wait a minute, please. So each lesson, so let's show the let's share the screen. Okay. So each lesson, I show you some, I give you some example like this, for example, you see on the screen, huh? So, and then here, for example, exercise 1, you have to solve it. Can you see that?
Yes, I can see that.
Yes. Yes, this is what I mean. Okay.
So should we submit this anywhere, or it's just a practice?
No, you do the homework, and at the end I will get from you. You collect it, you do it, you collect it, and I will get from you.
When you will get, hocam?
Let's say before end of the semester, 1 week before. But you shouldn't wait till that time, huh? So I will collect and I will evaluate it.
So the
and
homework
you will get
just all of the exercise?
Well, I couldn't understand what you mean.
Can you show the homeworks or just this one?
This is not only one. This is one of the examples. So one of the homework, huh?
Hojam, we mean if you can collect the questions or the exercises and put them as a file in course content, so we can access them.
Okay, but I will give you lesson by lesson. I don't know. I mean, I'm preparing.
Yeah, that's what I mean, Hojam. I mean, every time we finish a lesson, you just upload the exercises regarding that lesson.
The exercise into the Blackboard platform maybe, huh? Okay.
Hocam aslında bu slaytlarda konu anlatımı da olduğu için slaytları yükleseniz direkt olmaz mı?
So slaytlara yüklemiyorum hepsini.
Çünkü kitabı da yok hocam. Nereden çalışabiliriz dersi?
Yok, kitapta var. Bu size tavsiye ettiğim kitapta var. You have everything in this book. I recommend it.
Örnekler kitaptan mı hocam, bu örnekler?
Yeah, if you show some of them, but some of them not. But if you learn this book, you will manage it. Don't worry. You have enough knowledge.
Ödev mi peki?
Sorry?
Tüm örnekler ödev mi yoksa bazı örnekler ödev mi?
So I understood your problem, and I will collect it and put into the Orlearn platform. You will get from Orlearn platform, okay?
Tamam.
So then we will let's say define what is homework, what is not homework, and you will not be confused. Huh? Okay, now let's continue. I will put the homework for theory of machines on platform of Orlearn, and you will get from there. Okay, now let's continue. We were here from our last lessons. So we talked about the position and displacement. regarding the mechanisms. So then we are here on this page. Now we will learn how we graphically can define the position, let's say requested position, and also the requested displacement. So now we are going to use the analytical way. How can we calculate the position and displacement using the analytical method? So mainly we use let's wait here. So we use the two important laws. One of them is the laws of cosine, and the other one is the law of sine. And you see it based on the geometry, and you have here the triangle ABC, and the angle of this, the ABC, and length of ABC, the angle triangle. So we will use these equations, this law, for the analytical way of calculations. Here we have an inline crank slider mechanism. So inline crank slider mechanism. That means those are inline here. So on the same line, or let's say here, column here, they say this is A, and this is B, and this is C, the point here, or the joint. So A, B, C, and A and C are in the same line, on the same line. That's what I mean, inline crank slider mechanism. There is another type, and we will discuss it also in these lessons. So the analytical way, that means depending on this angle here, depending on theta 2, I'm aiming to calculate any position which is required. But in this calculation, what is known or what is given, L2, all the lengths, let's say the lengths are given, L2, L3 are given, but not L4, huh? Is not given, because this is changing, as you see here, depending on the position of C. And theta 2 must be also known. That means L4, we are going to calculate the L4 as a function of theta 2. So like this, eh? So as a function of theta 2. So how can we calculate that? We use as I mentioned, the sine theorem or sine law. And if you write, for example, let's say we are going to calculate the theta 3. So let's write sine theta 3 over the length here, theta 3 L2 is equal. So theta 2, we know that. Sine theta 3 must be here, theta 3. Okay. Then sine theta 2 over sine theta 2 over 2, that's right here, 2 over L3. Then if you solve these equations for theta 3, you will get these equations here. That means we can calculate the theta 3. And theta 3 is important, an important angle. Then we can calculate also the gamma. Gamma is the transmission angle, and a very important angle, transmission angle. So we transmit the power let's say from by L2 into the L3 and from here into the slider here. So therefore, this angle is unbelievably important. We will talk later also for this angle, about this angle. So this angle can be calculated since it is a triangle. So we know the theta2 and theta3. So this triangle, so we can easily calculate it for this example. And then we know theta2, theta3, and gamma. So then it is possible now to calculate the theta, say L4 using the cosine law. So this is the cosine law. We write here L4 square is equal L1. What is it? L4 square is equal, okay, L2, L3, L2 square plus, let's say L3, it doesn't matter, L3 or L2 square minus 2 times L3, L2 cosine L2 cosine gamma. So, and from these equations, we can calculate the L4. And so in such type of, let's say, such type of problem, givens are, so given are, for example, the L2, L3, and theta2. Theta2 is an angle which we use to derive the L2, the crank. I mean here, this member here, crank, to derive that. So you can imagine if we start to derive the L2 crank in the direction of counterclockwise, and we can calculate for each 10 degree of theta2, then at the end we get the position for C. We can get the position for C, and also we can calculate any point on this coupler. So this is very very important facilities if we know the let's say the length of the member of the mechanism as an inline crank. So we are able to calculate for each position let's say the displacement, and if you know the displacement, later on we will come to this topic. We can calculate, if you know the displacement, we are able to calculate the velocity, and we are able to calculate also acceleration. So since we can calculate the acceleration, we can also calculate the force coming from the acceleration. That means force of inertia. So then we have here an exercise I will put in the today on the platform, online platform. And what is the question? The questions determine the displacement of the piston as the crank rotates 95 degrees clockwise. That means clockwise in that direction. So this is the position, this is the initial position you have here with angle 65 degrees. So you turn 95 degrees in that direction and counterclockwise, and then you calculate the position. So then you have all these. You will do it. You can use two methods, but I need also the analytical way. You can calculate the analytically using the analytical method, and you can also use the graphical method to draw it. Okay, another type of there's a, let's say here's a small help actually how you can calculate. You see theta 2 is already here, can be calculated, and theta 3 you can calculate, and gamma and L4 and so on. This is possible to calculate. It's showing there. So another type of crank slider mechanism. So crank slider mechanism is offset crank slider mechanism. That means offset. That means there is a distance between this horizontal line. This is the horizontal line, and parallel to the horizontal line, the point of, let's say, A here, and B and C. So in this example, we don't have L1. L1 is here, you see. This is the L1 here, this distance. So in some applications, this crank slider mechanism used in that configuration, that the mechanism has an offset. It's an offset crank slider, so we have L1. That means we add one more parameter here. So to calculate it, one more parameter. Here we had only L2 and L3. We know also say the theta 2 is given. So, and here we have also L1 additionally. So how can we calculate now? Especially the L4 has to be calculated, because if we know the L4, the position of the point C, so we can calculate also the stroke here. So the slider here, the slider takes slider. So to calculate, first of all, we need to calculate the theta 3. Theta 2 is given already. So we can say here, so given R, given what? L1 is given, and L2 is given. That means we know all the parameters. L3 is given. So, and theta 2. Theta 2 we need to drive the crank. So this is the angle which we use to drive the crank, to move the mechanism, to put the mechanism in action, for example. And the find, what is the find here? L4 and gamma, and theta 3. Theta 3, so 3 parameters. And you know, we have to write at least 3 equations to calculate these 3 parameters. And you see here there are 3 equations, and also using these equations you can calculate actually all the parameters, theta 3, L4 and gamma. So how can we calculate? Is following. If I draw a perpendicular line to the base here, so, and you know, this is here parallel to the baseline here, and here is, as you know, this is L1, and this length here is L2 sine theta, L2 sine theta 2. So that means we know the length here, depending on the theta 2. L1 and L2 we know already. So then, using the sine theorem again, using the sine theorem, we can calculate it. So sine theorem, that means if you yes, write here sine theta 3 over the length here, L1, L2, so L1 plus L2 times sine theta 2 is equal here. We know also it's all it is. So wait. Okay. There's not. So I made a mistake. Sorry. I'm going to change it. So, since it is rectangular, so we can write these equations. So the sine theta 3 here, sine theta 3 is equal. We are using let's say the equations come from the rectangular. So L1 plus L2 sine theta 2 over hypotenuse L3. So from these equations, you can easily calculate the theta 3, as you see here. And L4 is equal, you write, if you know the L3 cosine, L3 cosine theta 3, so L3 cosine theta 3, and L2, this is here, L2 cosine theta 2, and this is the L4, and gamma is equal 180 minus theta 2 plus theta 3. So also very easy, we can calculate the parameter which we are looking for using the analytical method. So those type of calculation we call analysis. So that means we are analyzing. That means there is a mechanism given already, type is given, and dimensions are given. So we are analyzing. We are calculating position and displacement. Later on, also we'll calculate the velocity and the acceleration. So this method we call analysis. analysis. Okay. So, and there is also another important mechanism, 4-bar mechanism, often used in the technique, and we will discuss also this one, crank rocker. I have an example here, again to for this type of mechanism, offset crank slider, to make the calculation. You see here, this is L1, and this is L3, and this is L2 here, and this is the position, again, the mechanism used before, I mean, in that position. So we have to calculate, so determine the displacement of the piston. This is the piston here. Let's use another color here. This is the piston here, so on. So we have to calculate the position of the piston. Piston as the crank rotates 95 degrees. So 95 degrees clockwise, that means in that direction. 95 degrees. Okay. So another important type of mechanism beside of crank sliders, inline crank slider, offset crank slider, this is the 4-bar mechanism, crank rocker mechanism. 4-bar mechanism, you know, we may remember this is a crank rocker. It's the crank here, and this is the rocker. So we also take into account the Grashof rules. Smallest length plus longest length must be small from the others. I'm P and Q. This is, let's say, the smallest one. This is, let's say, smallest one. Mainly the L2, the crank should be smallest one. L1 could be bigger, I mean this one. And the summation of L2 and L3 must be less than L3 and L4. Then we have this type of mechanism, crank rocker. Okay, so, and there is two important position circuit regarding these mechanisms. One of them is the circuit 1 you see here, circuit 1 here, and the other one is here. It's the B. Here you see the position, different position. Here we have the angle. Here we have the angle like this here, and here we have the angle in opposite direction. So both of them are possible. So in this mechanism, in this type of mechanism, crank slider, the important is, as I mentioned it, to define the stroke. Stroke we have to calculate. So stroke we have to calculate. That's the reason why we are making, let's say, the analysis. And in order to calculate it, I'm in the L4. So we should calculate also theta 3 and gamma. It's also important. But in those type of mechanism, I'm in the crank rocker mechanism. The important is actually this angle here. The displacement of the point. you say there's a point, indicate the point like here, A. So the point A, B, B, C, and D. So that means the rocker, the motion of the rocker between this angle has to be calculated. And you use this type of mechanism, let's say, very frequently in technique. So if we need, so the motion, rotary motion in a certain angle. So that means this is a rotary motion here. This is the member DC is executing a rotary motion under a certain angle. And if we say the angle must be, let's say, 60 degrees, so it must be designed accordingly. So we will, in our next chapter, we will discuss the analysis. I mean, how can synthesis? How can they realize a mechanism coming from this angle, for example? So, or this type of the mechanism in the circuit too. So this is the important, let's say, the parameter we have to calculate, or the important values we have to calculate. So how can we calculate that? The way of calculations, you see here. You have these equations. Again, using the trigonometry, we can calculate what is given. Let's talk about first that. What is given? So given is L1. L1 is given and L2 is given. That means the type of mechanism and the dimensions are given. L1, L2, L3, and L4. L4 are given, and also theta 2. Always we need theta 2, because we use the theta 2 to derive the mechanism. So we derive the mechanism using theta 2. This is the driver angle in counterclockwise or in clockwise direction. So what is find? So any other expectations has to be find. For example, this angle is very important, as I said, since it is, if it moves, let's say, like so, into this, you know, this is a circle here around around the center of D. So let's say if we have such a motion and we have to calculate this angle, and we need to calculate the theta 4. So theta 4 has to be calculated. Theta 4. And of course theta 3. We need also theta 3 and the gamma, transmission angle, gamma. So those has to be calculated. And therefore, we use the analytical way to calculate it. And then first we calculate the BD. This is the length here. And then using the sine and cosine theorem, making some calculations, we can calculate the gamma, theta 3, and theta 4. So then we are able to calculate all other parameters based by giving L1, L2, L3, L4, and theta 2. Okay. for circle 1. Huh? This is for the equations for circle 1. Circle 1. These equations. So in case of circle 2, here you see that circle 2. So for 4-bar mechanism operating in second circuit, equations theta 3 must be slightly altered as follows. So we calculate theta 3 accordingly, and then based on theta 3, we have to recalculate the theta 4 also. Okay. Another important, I said the angle, this gamma here. Gamma is the transmission angle. So transmission angle. So you can imagine in that way. So if we have such a member, coupler L3, and if we drive this crank, so in that way, clockwise, that means there's a force acting on it. So F to transmit the power, F, and F and D. F has to be transmitted for the bar DC, and this angle, the most efficient way is this angle is 90 degrees. Must be 90 degrees, but it is not 90 degrees. So then it moves in between, let's say, the 40 and let's say 100, 120, and so on. The ideal angle. So there's an ideal angle which we has to be keep or realize for a good mechanism, the 4-bar mechanism or the crank rocker mechanism, and therefore we need to calculate the theta min and what is theta max. So that means these theta min and max values are important indicators for transmission of the power of the F from L3 to L4. Okay, so then we have an exercise here. One more. You see exercise 3. Determine the displacement of the 180 millimeter link. Where is it? 180 meter link is this one. So determine the displacement of the 180 millimeter link as the crank rotates 90 degrees clockwise. Where is the crank? Crank must be somewhere here. 90 degrees clockwise, that means here. So 90 degrees in that direction. From this position. So from this position, 90 degrees in clockwise, in direction of clockwise. So has to be calculated, and also this angle has to be calculated, gamma. So the and I am writing here and the transmission angle gamma has to be calculated. Okay, so though another topic belongs to the analysis is the coordinates, the coordinates of any point on the coupler. So point on a floating link. This is our, let's say, let's use the so this is our coupler. It is like a triangle. So any point on this coupler could be, so then we need to calculate the coordinates. In this example, let's say the coordinate of x here. So this is the position, of course. I mean, we have to calculate the position. That means the coordinates of the x. So you see, graphically, it is not a big problem because we know everything here. That means all the dimensions known. We are talking about the analysis, and therefore we know all the parameters of these mechanisms. Like we can say, given what is given here, givens are, for example, this L2. L2 is given, and here L3, L4, L4, and this is here L1. L1 is given. So given against L1, L2, L3, and L4 given. So also we should know the here LBX and LCX. So those must be also known in order to know the position of the x point x. But you know, this, since it is triangle, so these angles must be also known, and based on this angle we can easily calculate them. So so if the point B change, the position of AB change from the AB to AB prime. So let's say with those angles here, we learned already in our previous example. Also the rocker is also changing its position. That means the D is from DC to DC prime. So, okay. We discussed in our previous example. Now the problem is, how can we calculate the position of the x? So the calculation of the x, to orient the primary linkage points. For that, graphically we can easily find the position of the x. If we turn, let's say, with those angle, so let's say in the counter, sorry, clockwise, and here also clockwise, and of course this x moves from this position to this position. So graphically, it's not a problem. Using the compass and ruler and so on, and also the protractor, we can easily show it by drawing. But how can we calculate the position of x or any point on this coupler? This is a coupler. Any point on this coupler could be interesting. For that, we have, for example, here exercise, and the exercise is requested. The question here is, so determine the displacement of the bottom of the tire. You see the car mechanism where we assemble the tires to the car here. This is a 4-bar mechanism, you see. This is a 4-bar mechanism. you can see here easily. So this mechanism is very interesting topic in mechanical engineering, because nearly all the machines, all the equipment has different mechanism. And you see here the interesting applications. And we have here a spring. And we drive it by the spring. So you can imagine by driving the car, if we have a force like this somewhere here, so the force, or let's say it is going up and down, so because of the spring, so this energy pendling up and down, so can be absorbed or can be absorbed by the spring, but it needs such a mechanism to connect to the car, the tire. So this is a four mechanism. Those are the grounded points here, this one, and this is moving. So you see on the coupler, the tire is connected to the coupler. So like this here, this is tire connected to the coupler. That means the motion of the coupler is very important, especially this part on the coupler. And also, you see, it is also extended to this point. So this is a point on the coupler. This is a point on the coupler. So the question is, so if the upper control arm, this is this one. Let's use the upper control arm is this one, and the upper control arm rotates 20 degrees clockwise. So 20 degrees in that direction. So clockwise, 20 degrees. What is the position of the point here? Let's say X, the position of the X. So how can we calculate the position? Is it interesting? Yes, it is interesting and important also. Because the position and also the path of this point, is it, let's say, does it move vertically? Or vertical up and down, that means 100% vertical, because you know the tire has to keep the street, so, and it shouldn't turn. Let's say it shouldn't change its position in that direction or in that direction or in other direction. So how can we design a mechanism that the position here, any points or the points on this tire for a certain angle of this upper arm, upper control arm, undergoes a linear motion. So for a certain angle of upper arm. So this is the this is the art to calculate, that means to design such a mechanism. Then if we talk about the design, this is analysis, synthesis. So this is we discuss under the term of synthesis. That means we design a mechanism. So we expect from this mechanism that this point here. Let's say on the coupler undergoes a linear motion. At least not fully, but for a certain angle of upper arm. So you have to do this. You have to do this exercise. So I will put on the e-learn platform. Okay. So what happens? So let's make 10 minutes break, and after 10 minutes we meet again. Huh? So we have 14.3 and 14.13 we start.
Okay.
Or 14.15. Let's say 14.15 is okay.
Okay. It's okay.
So we can start. Can you see the slides? Is it
Yeah.
everything okay?
Yeah, it's okay.
Okay. So now we are. I'm going to talk a little bit about the transfer function. So we said transmission angle, so transfer function. You shouldn't mix it. So what is transfer function? So if I let's use this mechanism here, and this is, you see, this is the XY system here. This is the X axis, and this is the Y axis, like this. This is the Y axis. This is the X axis, and let's assume that this link here, crank, is moving, so in that direction, counterclockwise. So, and this is the angle theta. We said theta 2. We use theta 2 for that. So if I drive this link, that means let's use also the letter here, A, B, and C here, the joint indicated by A, B, and C. So if I drive the link AB in counterclockwise direction, angle by angle, let's say from 0 to 360 degree, So, and I'm checking the position of the point C. So C is moving in that direction or in that direction, isn't it? So, and I'm going to calculate the position of C, or the coordinates of C, based on the angle. This is the, here you see, motion of output link. Let's say the motion of output link. Motion of output link, and this is the output link here. Output link, this is the piston here. Our piston is the output link, and the crank is input link in that sense. This is the input link here, this one. This is input link. Has a extension here. Why? I will talk later about. So this is the input link. Let's write here a column. Input link. Input link, and the yellow one is the output link. So output link. Okay. So the input link moves from, let's say, it undergoes a rotary motion, rotary motion, and this rotary motion is from 0, as you see, from 0 to 360 degrees. So 360 degrees. This is the motion here, from 0 to the 360. That means one full cycle. So the motion of input link. So, and we, let's say, let the input link run. I made a mistake, sorry. Link here, this must be link. And this also output link. So then comes again here. So let's say these input links turn one by one 360 degrees from 0. And for each angle of the input link, I have to calculate the position of C, the point C, and the position of C. And the position of C as distance, I'm going to indicate on the y-axis. This is, let's say, this is the x-axis showing the angle of driver angle of the input link, and this is the y showing the position of the output link here. And you will see, you should do that. I mean, as an exercise, I will give you an exercise. So you will do that and you will see that. So for each angle here, you have a position, and here for each angle, you calculate a distance of this let's say we learned also the limiting position of this type of mechanism. So limiting position, this is the minimum, and this is the, let's say, the maximum. Go here to the maximum, max. So this is the min, and this is the max here. So it starts with min, that means with near to 0, and goes up. So this is the maximum point here somewhere here. And this maximum position achieve. This is the full stroke here. Maybe let's say triangle, but this is not centric, this is not inline, this is offline, therefore it's a little bit far away here. 350 is somewhere here. So, and arrive its maximum, and that means goes forward and then come back to initial position, fulfill its stroke like this. So it goes here in that direction, and in this part back to the initial position in that direction. So that means goes in that direction and then back to the initial position. And if we put this distance on the y-axis, so we achieve such a curve. So this is the curve of, let's say, the S stroke here. It's indicated with S. S is as a function of what? As a function of what? So who can give the answer? I'm waiting for the answer. As a function of what? So you learn mathematics, you finished, I guess, already mathematics, huh? So S stroke is dependent parameter here. And the function of what? That means L4. Huh? We discussed already. L4. Huh? L4, you see, where is it? Here. L4 is a function of theta 2 and also theta 3, but theta 3 is also a function of theta 2. So that means L4 is a function of theta 2, because we changed theta 2, and depending on theta 2, we calculate the L4. So L1, L2, L3, theta 2, this is wrong. Theta, it must be theta 2 here. Theta 2, huh? L1, L2, L3, theta 2 given, and L4, gamma, theta 3 has to be calculated based on these given. So the L4 is a function of theta 2. Theta 2 is independent variable. L4 is dependent variable, like we are discussing here. So independent, okay. So here S is a function, independent, a dependent variable, and depends on theta 2. And theta 2 is the angle of input link, driving angle of input link. So this we call transfer function. Transfer function. So what means transfer function? Transfer function means the curve of the output link, or the curve part of the output link, let's say, or curve output link undergoes, depending on the driving angle theta 2. And depends on the geometry of the mechanism, like L1, L2, L3, and so on. This curve is changing. So you can achieve different curve if you change the diameter or dimension of the mechanism. So this is also a important information for us. So this is the, let's say, the displacement curve. Displacement curve based on the angle of the input link. So, and we can calculate the velocity and the acceleration using this curve or using these facilities. So you can say the transfer function or the displacement diagram. So still we are busy with the position and displacement. But why we are discussing so much the displacement and position and displacement? Because our interest is actually velocity and acceleration. This is our target, to calculate the velocity and acceleration, to design a mechanism, to define the dimensions of a mechanism for a given applications. So, but on the other side, it's also important to calculate the velocity and acceleration for the further steps. So therefore, first, we learn the mechanism, so which type of mechanism we apply the most frequently in the machine design or the machinery, and so the position and displacement, and then we will come to the velocity and acceleration. So then, okay, so we calculate the position, let's say the point C here, motion of output link. So, but it could be also like this. We have a 4-bar mechanism, and we will talk about Coupler curves. That means a point on the point A on the coupler here. This coupler, like a triangle. So, and there's a point here. Let's say the A, could be anything else. And our interest is the coordinates of the point A. So how can we calculate the coordinates of the point A? So the way to calculate it is that like this, we can calculate the AX, the X value. This is the X and Y coordinate system. X is equal here, L2 cosine 2, what's L2? L2 cosine 2 here. So this is this part here. Let's use the pencil. So S2 cosine. So this is this part here. And then plus A cosine theta plus theta 2. This is theta is given here. You see, this angle is given already. Here, theta. And theta 3 is this angle, you know. We already discussed in our previous lessons, theta 3. So this is the length here. It is also given as A, must be given because the triangle must be known. So A cosine theta plus theta 3A. So, or A times cosine theta plus theta 3. So then we have the coordinate, X coordinate. Then the Y coordinates, in the same way we can calculate the projection of the point A on the y-axis, and this is L2 sine theta 2 plus A sine theta plus theta 3. For theta is equal 0, that means any point on this bar here, BC, can be calculated in that way. We set 0 instead of the theta, and we have these equations. So then we can calculate the coordinates of any points A on the BC, depending on A, of course. Huh? Okay, so then at the end of this chapter, we came to this stage that we can say for a 4-bar mechanism, let's say the givens L1, L2, L3, L4, and theta 2 must be given. So we can calculate, we are able to calculate, to make an analysis, we are able to calculate theta 3, theta 4, gamma, AX, and AY, and we can show as a graph. So then I did an example. So is it here? So you can create an Excel table like this. And what is given here, L1, L2, L3, L4, and A, the eccentricity, and theta 2, and BD is the parameter in between we calculated here. You see that. Where is it here? This one here, the BD, you see. Okay, then, and okay, gamma, transmission angle, and then theta 3 and theta 4, AX and AY. So you write the formula here, you see the formula here. So, or how can we calculate the theta 3 or 4, and how we can calculate the AX, and then so on. And then at the end, you have all the coordinates of theta, AX and AY. And you see here the graph. This is AX, AY, and this is the angle theta 3. We can show also the gamma. The gamma, where is the gamma? Gamma S could be also interesting. The transmission angle, let's do it also, the gamma. Okay. Here. Okay. Gamma, let's. Okay. So that means the angle gamma is changing in between notice something is wrong. And okay, let's use this one. And you see here the coordinates of the curve curve described by AX and AY. That means the curve undergoes the point here, the point, where is it? Point X, point A, sorry, the curve, the curve, the point A undergoes. Where is it? Okay, here is the curve. And this is the angle theta, the changing, let's say, in between, let's say, 100 and 100, for 100, 140, 40, 44, and so 45, 40, 45 maybe. And here we have the, gamma we had already, sorry, take it out. So gamma we had. So let's take it out. Okay, we had already. The gamma, this is the angle. This is the angle, the transmission angle, so over the x-axis. So you see it moves between 60 and 110. So between 60 and 110, we can use a line, and where is it? Okay. Here, if we use this line here, okay. Nearly 60 degrees, or 90, let's say 90, uh, 95. Till here. So the 100, around 112 or 15 and so on. We can see from the table that you see the transmission angle is changing in between. So, and we will see later on what are the limits of what should be for a good transmission. What should be the limits of transmission angle? So that means you can calculate what is necessary, what you need based on these given here, and you can make analysis, and you can calculate any other parameter you need for the mechanism. So theta 4, where is it? Theta 4. So theta 4 is this angle. That means the angle we use for the oscillation, and we need for the oscillation. And theta 4, do we have somewhere here? Theta 4, for theta 4 is here. You see, it is moves between these two. We can use this line again. Copy. Okay, let's copy that and put here. So it is changing in between here. 10 and so between let's say 101 and between 100, 140, 40, 45, and so on, 45, and so on. Huh? So in between, that means if we check again, so the angle is start from, let's come from this minimum value is somewhere here. Use this pencil. 100 more than 90. Let's use another color. Is better to, okay, this one. So it is moving from, let's say, from this angle to this angle, huh? So in between. Oh, sorry. It is already here indicated, but it is wrong. Of course, this is another example. So in between, huh? Our rocker moves in between. This is the angle. So we use for we create the oscillation by the link DC. So this angle. Huh? If we need different angle, the motion, angular motion here in between, so then we have to redesign the mechanism. That means we have to change the dimensions of the mechanism in order to achieve a different angle here. So, and that we will learn in the synthesis. Okay, we came to the end of these lessons. We will start a new topic next week. I will start. I will suggest that we start next week. This topic will be the synthesis. That means we are going to discuss how can we design a mechanism. So design a mechanism, that means how can we define the parameter like L1, L2, L3, and so on, so that we create desired or requested here the angle, the motion, or like in this mechanism, the stroke. So how can we let's say achieve the given stroke by designing the mechanism, by making synthesis. Okay, do you have any question? Okay, then see you next week. Bye-bye.